Good morning, everyone. Welcome to the Heartbeat ETK Technical Conference. Today we'll just have one presentation, which will be about Aztec Updates. We're scheduled to end at the latest 9 a.m. Pacific Time. This presentation will be recorded and accessible online once we've processed it. If you have any questions during the presentation, please type it in the message box provided. And also, please mute your mic during the presentation to prevent any background noises. So today, Brian and I will give a few updates regarding our overall progress on Aztec. I know Professor Wong presented updates at the PI meeting a few weeks ago. We'll be going over some of those new features in more detail and also talk about our new goals for the spring. So we'll start with a very quick overview of Aztec, and then I'll explain the existing features we've implemented. Brian will talk about different projects that we're working on, and we'll end our presentation with a short demo of the new submission form. So Aztec aims to provide users with a global biomedical resource discovery knowledge base to search a diverse array of tools. The resources indexed include web services, standalone software, publications, and large libraries composed of many interrelated functions. We're aiming to ensure that software tools remain findable in the long term. And one of the ways we'll be doing this is by routinely updating metadata for the entire database. So here's a diagram of our overall workflow. So Aztec workflow provides user with rich information about biomedical resources and is comprised of 3 steps. The first one is discover, second one is review, and the third one is publish. The purpose of the discovery step is to find resource metadata to input into our database, and we do this using our web crawlers and metadata submitted through user submissions. The web crawlers crawl existing biomedical registries, code repositories, BGTK related websites, scientific literature, and we extract relevant metadata about the biomedical resources. And then the metadata platform was designed for users to manually input their resource metadata into the Aztec database. And then the purpose of the review step is to examine the content extracted by the web crawlers and submitted by the users for accuracy and quality. And then our reviewers will also enrich the metadata of the resources by referencing online resources. And our reviewers will ensure that the resource metadata is complete before we publish it to the public Aztec website. And then the purpose of the publish step is to make all resource metadata that we've published by our reviewers available to the public. So this includes creating and maintaining the web user interface as well as the REST API. So currently we collect resources from 6 different sources. Both ELIXIR and BioCatalog are existing resource registries. Bio.js is a repository for JavaScript libraries for visualizing biological data. Bioconductor is a repository for R packages for analyzing high throughput genomic data. And then Galaxy is a web platform for creating and running pipelines for biomedical research. And then Cytoscape is also a platform, but mainly for visualizations. And we're also in the process of integrating metadata from SourceForge, which hosts code and binaries from open source projects. Currently, Aztec features a search platform that allows users to search for tools using keywords and a set of filters. This search platform was built off of Solr. We have implemented the resource submission form that allows users to input metadata pertaining to a specific resource. The login system provides a layer of security to the search platform. While all users have access to the search functionality, only authenticated users can submit and edit resource metadata. And we also have Google Analytics integrated to track user statistics on Aztec. It'll tell us the number of users that access the website as well as which resources have the most visits. I'll quickly go over some of the screenshots of the current Aztec website. So this is the home page. On the top, you can see the search bar. This is the first thing that users will see when they first visit the website. And if you scroll down a bit, you'll see the statistics about the type of resources in Aztec, as well as our site traffic, which is retrieved from Google Analytics. When you type in the search box, you'll see an auto suggestion box pop up below the search box. So in this example, when I type biological pathway, I get Reactome as a suggested resource. And once you hit enter, you get a list of results. On the left-hand side, you see the different metadata fields that you can filter to further refine your search. And then if you click on one of the search refinements, your results will change accordingly. And on the right side, you'll see the search history, which shows all the search refinements that you made. And when you click on a tool, you will go to the tools page with all the information about the tool. We're actually working on redesigning this page for a more simple and less cluttered look. But right now we're focusing on populating the resource metadata of the tools in Aztec. As you can see, this entry has very little metadata, and that's because some of the sources that we retrieve our metadata from provide very little metadata. So we're looking into different methods on enriching the metadata for each resource in Aztec. And then here we have our resource metadata submission form. As you can see, this is a fairly long form, and we've provided a fairly exhaustive set of metadata fields. In the past few months, we've been evaluating these fields, trying to figure out whether they're important or unnecessary. We've also standardized some of the metadata fields, which Brian will be talking about next, and we'll also be demoing a new submission form that we've been working on.
Hi, this is Brian. So I'm going to talk about our progress towards standardizing the metadata schema. So when we first built our Aztec prototype, most of the fields were free text. So, if someone was submitting a new tool, or if we were reading a tool from one of our online sources, it was free text, all the metadata fields, so they could basically be anything. So someone could put in UCLA for the research institution, or they could put in University of California, Los Angeles, and then those might be considered separate entities. And you want to be able to identify everything produced by UCLA if something's listed as University of California, Los Angeles. So we've made an effort to try to standardize as many of these fields as possible and set up a controlled vocabulary for the majority of the metadata fields. So for programming languages, we've gotten a list of well-defined programming languages from GitHub, and because GitHub's obviously the most popular source code repository in the world, it's a really good vocabulary and covers almost any conceivable language. For platforms, we ultimately just decided to keep things simple and reduce it to four platforms. So the user will have to pick one of these, and this should cover almost any situation. And for example, if a program is available to download and run on like a Windows, Linux, or Mac computer, but it's also available as a web service, then it'd be Linux, Mac, and web. So the web option is agnostic to whatever platform the tool is actually running on. Just if it's available to a user from a web service, then it'll be listed as web. We got a list of research institutions and universities from Wikidata. This is a very, very large list, over 5,000 institutions, so it's very comprehensive. We have aliases also for those, like the university example I mentioned earlier. So any institution that has a common acronym or a common nickname will link to the same entity. Software licenses, we've also gone with GitHub. That makes it easy for us to automatically populate the field, because if we have the source code repository for the tool, we can automatically retrieve it from GitHub's own metadata system. For funding agencies, we use Crossref. Again, this is a very comprehensive list of agencies, thousands of agencies, including international agencies with aliases. For biological domain, we're going to be using EDAM. EDAM, I believe, has 16 top-level biological domains. For authors, we're still working on a system to standardize authors. So obviously, there are many different people with the same name, but we're going to be using the ORCID ID where available, the GitHub username of the author where available, and their email also to try to make sure that each author of a tool refers to a specific entity. So our plan is that we will, if you click on a tool, you'll see all the authors that we know of. So the people, for example, the GitHub contributors that we have there, the first and last name, people listed on the web page. So all those authors will be listed. But if you want to be able to use Aztec to see all the products of the author, you're not going to be able to do so unless they have an ORCID. And for file formats, also we're going to go with the EDAM ontology. Let's see. So for metadata extraction, we're going to be using the Grobid, which is an open source Java tool to automatically pull metadata from publications. We'll be able to pull the authors, the institutions, the tool description, which is the abstract, and links, so URLs mentioned in the abstract. And we'll identify the type of link automatically, so we'll be able to tell if it's based on the actual URL and the words in the sentence surrounding the URL. We'll be able to tell if it's a source code repository, if it's a place you can download the actual tool, if it's the tool's homepage, and we'll be able to categorize those links appropriately. And also we'll identify funding sources and tags, which will give us keywords to help people find tools in searches. So the metadata extraction, it's going to be offered as both a tool where a user can upload a publication if they want to submit their own tool to Aztec to help them pre-populate some of the fields that they would be filling out the tool submission form. They just drag in their own publication, and it'll help make things a little bit easier. But and that'll be how we'll be initially releasing this feature. But ultimately, this is going to help us extract a lot more metadata from PubMed and publications released online. We're working right now to increase the quality of the metadata for different tools. So not all the metadata is going to be found in the publication or in whichever source of the 6 that Vincent mentioned earlier we're pulling the tool from. So we're gonna be checking multiple sources for metadata. So for example, if we have the excuse me. So authors will, for example, will be able to be retrieved from both Crossref and ORCID. We'll be able to compare these results together and make sure they're consistent. Um, and we're going to try to use that to measure the accuracy of the tool metadata. So we'll also be able to check, for example, GitHub to find the authors, and those are independent sources. So Crossref and ORCID are related, where they derive their list of authors from using the same methods, but GitHub is independent. So if we find a lot of consistencies there, like find the same first and last name, the same emails for the list of authors, then that's going to let us know that we have high quality metadata, and that'll give the tool a positive weight to help it rise to top of search results. And if there's a lot of contradictions, then that will lower the quality of the metadata, and that'll bring it to the attention of our review team, and then it'll also give the tool a lower weight, so it'll be less likely to show up at the top of search results. We're also trying to improve the search. As Vincent showed in the slides earlier, we've integrated autocompletion. We also want to include biological synonyms to increase search accuracy. So we'll be using both mesh and EDAM to increase the number of synonyms. And as I mentioned earlier, we want to add weights to resources based on metadata completeness, source repository metrics. So the amount of activity on a repository, indicates how popular the tool is, how useful it is to people. So a great number of forks, commits, pull requests, and contributors. Also, the most if they're using GitHub to track releases, if it has more recent releases, shows that it's well maintained, and therefore be more likely to be bug free, more likely to be useful to the community. So more recent releases will also increase the weight, and then publication citations and alt metrics. Alt metrics will gauges the number of mentions in blog posts, Twitter, news articles, etc. And some more new features we're working on. Front page redesign. We're going to try to make better use of space, get more information out to the user, and just give in general a better visual appearance. We allow people to search by dates, so they'll be able to search both by the date that a tool was released and when a tool was last updated. So obviously, if people are more interested in more recent tools, but also even a very old tool, if it's been continuously updated over many years, then it's obviously still useful to the community. So people still want to make sure that they're getting tools, even if it's an old tool, as long as it's being updated, it's still useful to people. And also a new submission form, which Vincent will now demonstrate.
Alright, so here's our new submission form. It's broken down into 8 different sections instead of having just one long form. So here we start with like a section for basic information, which includes the resource name, the description, logo URL, the resource types, biological domain, and tags. And then on the right side, you see a summary of the information that you input into the form. So for example, if I enter my variant.info, it'll show up on the right side. And then another feature that we have in this right-hand panel is the suggestion box. So if you click suggest and then click on the button, you'll get some suggested information, such as the GitHub URL and the publication URL. And then in the let's see, next, so in the authors section, you can add as many authors as you'd like. Same for maintainer. And then right here for institutions, this box is the auto suggest box. So we've, as Brian mentioned, we populate the data with from Wikidata, where we've pulled all the universities and research institutions from the database. So if I type in TSRI, it shows up as the Scripps Research Institute. And then next we have the publication section, and it will take in the resource DOI and also the primary publication DOI. And then if you have other publication DOIs, you can add accordingly. And then for links, yeah, same here. You can add a link, just put the link title and also the URL. In the development section, if you input the GitHub URL, so let's see. So I'm going to copy and paste the URL for the GitHub for myvariant.info, and then if I click suggest, give me a little bit more information about the tool. So it says the GitHub language is Python. So I can come here and then add the programming language, which also is an auto suggest box. So if I type Python, it should show up. And then platform, as Brian mentioned, we've listed out 4 of them. And the next section, so the next section is for versions, and you can add accordingly. And then we have the input-output section, which we're still working on, but that'll be a later feature. Licenses, we've pulled from GitHub. So if you add a license, in this case, GitHub says there's or other, or it says other. So add other, and then you can input whatever information about that license. For the funding agencies, we've pulled from Crossref. Currently, we have over 10,000 funding agencies in our database. So you can put in, NIH or Wellcome Trust. Yeah, so it's a pretty big list of funding agencies. Also, once you're finished inputting your metadata, you have the option to save. Hold on. Test. So you can save your resource, so you can come back to it later on. And then once you're okay with your information, you can click submit. And then before you submit, it'll show like a warning box telling you the different metadata that you haven't entered yet. But if you're okay with all the warnings, click continue. This part right here, we're still working on it, but it's supposed to show like a summary of all of the metadata. And then there's a CAPTCHA, and then you click submit, and then it'll process it and enter it into our database. Yeah. So that's the demo. Moving forward, we're hoping for a beta release in the early summer to invite users outside of our lab and center to test Aztec and give us feedback. So we'll be incorporating sort of an iterative cycle in which we'll have regular communication with our testers, gather their feedback through surveys and tracking user interactions through Google Analytics. And then we'll make the necessary changes on Aztec and release a new version to see how our testers respond to the new changes. That's it for our presentation. Thank you for listening. We'll be happy to take any questions.